Hello and welcome to Precalculus. We're back with the last section in chapter 1. Now let me check if the stream is actually going. Yep, it is. Okay, good. Don't worry about it. I got that. So with mathematical modeling, what we're doing is we are taking the, as you would say, and I hate that phrase, a real life situation or the real world situation, and you write mathematical function, mathematical equation to explain it, to model it. And you can use that one to compute the future. So the models can predict many things, changes in prices, various engineering, physical behaviors. We can predict the weather. Weather model is very complex. And let's see how we do these things. So you had the preview in your algebra class with writing equations. Now these are going to be a little bit more involved. And as I said, we're going to take all of these problems, all of these functions, and bring them to calculus and do even more with them. So don't forget these types of problems, these forms, because certain things we will not be able to do here. We would have to use the calculator and kind of cheat a little bit, especially for your labs. But then when you get into calculus, you will have the word for word the same problem. So literally cut and paste from this book into your calculus course and then just ask extra question regarding it. So the modeling will remain the same. Whatever you learn or forget now will impact you in the next course. So the first example in a textbook is talking about choosing between two texting plans. Now, I remember the ancient days when it was the minutes that were important for cell phones. So how many minutes you can talk. You were charged per minute. Then the new iteration is texting. But now texting is free as well and included. Today we should actually have this one as data plans, right? Because today you don't have unlimited data, most likely. You have whatever gigabytes, and then you are trying to see how the pricing works, and then if you go over, you have to pay extra and so on. Now, I want you to understand that doesn't matter what we are talking about, mathematical principle behind the calculation is the same. Whether you are talking about the minutes, and then you pay for extra minutes, or you're talking about limited amount of text messages and then pay per extra text message, or you're talking about limited amount of gigabytes and then pay per extra gigabytes, all of them actually have the same principle. So let's just talk about whatever the problem is there, but then you know that you can transform this problem into anything else. And as the stuff updates, you will be able to modify the problem again and then go on. So you are choosing between two texting plans. Plan A has a monthly fee, Plan B has a monthly fee, and they also have those fees that are extra. So let's take a look. So Plan A has fixed $20. Oops. So $20 fixed plus 5 cents per message. And the Plan B has $5 fixed and 10 cents per text per extra message. Maybe I'll just change these into text. So every extra is the next text. So the question is, which of these plans is better? And that's a very tricky question. This is a very tricky question because it depends on what? Exactly. So you can actually use this. You can use this to, when you're comparing two plans, you can use, and because you should know yourself and know if you are really a social bug and have 5,000 people there, and you're constantly texting, or you have one person in life and you get text message every other week. So let's take a look. What would be the cost for plan A? So cost for texts for plan A. So how would you write an equation for this? Yes. Yes. Plus 0.5, very good. Because 20 is given in dollars, and you have to transform your 5 cents into dollars as well, because you should be adding the same units, dollars plus dollars. So the cost for plan A is $20 fixed plus 0.05, which is 5 cents, times x, and x would be the number of text messages. So we're going to define this x as number of text messages, number of texts. See you next week. It doesn't matter. How about cost for B? Excellent. So now we have $5 plus extra texts, right? But now, how would we decide which plan is better? Yes? Uh-huh. Okay. So that's the type of analysis we would say trial and error. Can we figure out anything? Yes? Correct? Why would I do that?
Put them at a break even.
Yeah.
Nice. That's the business mind, right? That's the business mind we need. When you set these two equations equal to each other, you will find that the number of text messages that you're sending to break even, which means both plans will cost you the same. If you look, what you have on the left-hand side is the cost for A and the cost for plan B. Those are equal to these equations. Setting the equations equal to each other is equivalent to saying that the cost for both plans are the same. So by setting these two equations equal to each other, we will find x for which it doesn't matter which plan we take because they both give us the same value. So the way we compute this is we combine x's together, so we'll move 5 over, get 15, and we'll move this one over there and get 0.05x. Then we would multiply both sides by 100 over 5, and we'll get x equals 300. Awesome. So do this, you solve the equation any way you know. That's elementary algebra, this equation. Yes. I moved the 5 over and 0.05x over. Combine numbers, combine. Why is it I move them in such a way so I don't generate any negative numbers? I just left everything positive. Now you can generate negatives on both sides. When they divide, they would cancel out. So, guys, 300 text messages. If you are a person who sends exactly 300 text messages every month, that means that you guys have the... it doesn't matter which plan you're picking. Because when you plug in 300 in either one of these, you will get the same value. 300 times 5 times 0.5, right, is 15 plus 20, 35. 300 times 0.1 is 30 plus 5, 35. So you will pay $35 with either plan. Now, which plan is better if you are going to send 400 messages? 400 messages is A. And how about 100 messages? B. There's no C option. Whoever said C. So now from here, you can say less than 300, more than 300 messages. Observe that I don't put equal sign on any of them, because if it's equal, it doesn't matter which plan you use. So for less than 300, you will use plan B. For more than 300, A. And that is the analysis that we do. Now, how many of you computed this before you went and chose the plan? No one, right? Because it's free, right? How many of you computed it for your gigabytes of data when you chose the plan? You see? You could have. But we don't do it.
Horizon, there's like 3 extra letters and like small print on the bottom.
Yes. Now, I don't have it with me, and I regret that. I usually bring it with me. I could go and get one, but they might be closed. Yeah, they are. Oh, no, they're not. What do you think, where would this calculation be crucial to make an important life decision where you could compute something like this? Yes? You usually get offers in the mail, and you just open up whatever comes in. Mortgage rates? Mortgage rates now? Nope. They're pretty much always the same. Nope. Yeah. Nope. Not food? There we go. Picking a healthcare plan. You're going to have 7 different options, 8 different options, 10 different options if you're working for a good company. They're going to give you 10 different health care plans. And one of them is going to say, no co-payment whatsoever, this is the price. You pay for this doctor this much, for that doctor that much, and so on. The next one's going to say every time you go to the doctor it's $10. The next one says $15, then the $20. Then you have the monthly payment, and you have also how much you would go for medications, how many for dental plan, how many for vision. Guys, that decision doesn't only go for a paper and say, dude, what did you choose? 3? Right? Because it depends person to person. If you are going to have a $10 copay every time you visit a doctor, and you have a condition that gets you in a doctor's office twice a week, that's not a good plan for you, because you're out $20 every single week for sure, right? Whether you have to do something or not. You're going to choose the plan that has 0 for the copay, right? See? So you do this calculation, and then you figure out which healthcare plan would be the best. Now, yes, you can use this for the car loans, and you can do this for leasing the car or buying the car against the down payment. Maybe you are looking into getting a Tesla, let's say, right? It's $85,000. Got to figure out how to get it. So, yeah, Model 3 is 35, but still doesn't exist. So, you want to give me the 35? I'll hold it down for you. I'll hold it down until that one is in. Why not? I'm trustworthy. Ask all 4 people who did that. Actually, you can't, but they would say good things if they could. Now, also one more thing that I would note here is that both of these equations are linear equations which you can graph, and they would both be like this, and they would intersect at the point. This intersection point is at x equals 300, because it is the 300 where the same x gives the same price, and the price, which is dollars, would be on the y-axis. So this is where the money is, on the y-axis. And that was 35 bucks, yeah, 35. So this would be 35 over here, if the pen worked now. I don't know why. Yeah. Does anyone have Apple products so I can smash it now? I'm angry. Ah, there we go. Now I gotta change the battery in this thing. It keeps disconnecting, which is really annoying. Or it won't let me put the price at 35 bucks because that's too expensive.
I think he said it's the first one today.
I'm pretty sure it's procrastinating, so probably won't get done until the end of the year.
Probably. All right. So, it's not a triple A, it's quadruple A. All right. Cool. The next problem is really awesome. I had this one on my project for Calculus 1 in its expanded mode. And it deals again with some kind of business decisions, money again. And it says that on a certain route, an airline carrier carries 6,000 passengers per month, each paying $200 for a ticket. A market survey indicates that for each dollar increase in the ticket price, the airline will lose 100 passengers. So express the number of passengers per month and as a function of ticket price X, and the airline monthly revenue, right? What's the revenue in terms of the number of passengers? So we should start by understanding what the problem is asking us to do, which is to have 6,000 passengers on this line if the price is $200. And then they say, for every $1 that you add, you will lose 200 passengers, so this goes down to 5,800. When it's 202, it goes down to 5,600.
Wasn't it 100 passengers?
Oh yeah, you're right. We lose 100 passengers. You're right. It was $200 for a ticket. So we are losing 100 passengers every time you increase $1. This is enough. So we see that on this side we are experiencing +1. On this side we are experiencing -100. And that's the pattern. The market surveys are actually done. This is all real stuff. It's how it's business work. And we are supposed to come up with mathematical equation that will help us figure out what is that sweet spot. And we'll talk about it once the problem is solved. So if we are increasing the price of a ticket for $1, we are losing 100 passengers every month. So how would we model this? Yes. I'm sorry? 6, 7? Oh, 6,000. What do you say, 6,000? But how would you write that? X minus 200. Huh? In parentheses? X is supposed to be price, yeah. But no, we can keep P for price. Let's put P for price. Capital N is the number of passengers. Yes. Eventually you will.
What are we trying to find? Just an equation?
Equation that models this type of data. It's going to be number of passengers is equal to some kind of function of price. It's definitely going to be 6,000 minus something. It has to. That's clear. But what is that piece that we keep subtracting?
No,
Isn't just a bracket?
Now, do we all see the pattern that when you lose 1, you lose 100, you lose 2, you lose 200, you lose 3, you lose 300? Do we see that? So this is the way you should think about it. Create a counter. Any programming majors coming along or from this room? Nope. That's why it's so difficult. If we had one of those, they would be done by now. This is exactly how computer programmers must think at all times. And this is this is for you guys, if you exist here. Create a counter, and then you will multiply that counter by 100, and that should represent the loss, and you take that away from a 6,000. So how do you create a counter? Well, it's the new price P minus the old price 200. That is going to tell you what's the difference, which is the multiplier for 100 people that you will take away from 6,000. I hope you looked at the board where I was writing this. I'm going to write it again the same way and say it. So stare at the screen, not at your books. Screen. Now, I'm going to take whatever the new price is and take away 200 to create a counter. So new price could be 204. Minus 200 is going to give me a counter of 4. 4 times 100 means that I'm losing, with a minus, losing 400 people from 6,000 where I started from. So I'm now going to get up over here at 2 calories and look at this. New price, let's say 203, minus the old price of 200 gives me a counter of 3. 3 times 100, I'm losing 300 people. Take that away from 6,000. Do we all understand the model?
Yes.
This model works for everything except for Apple products. The worse they make it and the more expensive they make it, more people buy it. Where's your headphone jack? I know. All right. Now what? We got the number of people with respect to price. So if you tell me now that you want to put 210 price, I will tell you that you lose 10,000 people. sorry, 1,000 people. So you will have 5,000 on your line. So this is the first part, figuring out mathematical equation. With this mathematical equation, you can work wonders, because you can now figure out what is the actually best price for you to make most money. Because the revenue, which is all of the money that you collect, is going to be the number of people using the airplane times the price you set. But you know that the number of people is this. So you can plug that in and you can work out the equation for revenue. And then you know what your costs are, subtract that, and you have the what's the revenue minus the cost? Profit, thank you. All right. So revenue is going to be our good old N. So that's 6,000 minus, and I'm going to distribute this now, 100p plus 2,000. So if you solve it, times P from the revenue. And then R is equal to, this is 6,000, 2,000, 8,000 times P minus 100p squared. So what I did is I combined like terms, 6,000 plus 2,000 is 8,000 times the p on the outside, which distributes, and then minus 100p times p is p squared. And here's my equation for revenue. I have this revenue equation. Now, what I can do, I want to maximize the revenue so that I want to maximize the revenue, minimize the cost. We don't do that minimizing cost here, but if I maximize the revenue, minimize the cost, that will automatically maximize the profit. Now you take the business courses to figure out the details of that. Mathematics is there to support all of those courses later on. So now you have this equation. If you observe, the squared term is what? Yeah, squared term is what kind of number is that 100 over there? Negative, thank you. So if it's a negative, it's going to look like this, right? It's a downward opening parabola, which means it has vertex, which is a maximum. Good. So at that vertex is the maximum, which is the maximum revenue. So now, if you use the formula for vertex, let's go algebra. What was the formula for computing the vertex? See? No one ever fails precalculus. That's easy, right? It's the algebra that kills. The prerequisites, right? I haven't heard a single person whining about that. It's just, I don't remember how to divide polynomials. It's algebra. Wait for chapter 2. Anyone? Negative b over a? You had enough, huh? I got you.
I'll do that. Thanks.
So b is 8,000. So we have negative 8,000 divided by, oops, that's 2a. The pen didn't work. Negative 200. So it is 40. P equals 40. Maximum revenue. Needs to be 240, not go down. Needs to go up. It's awesome. Okay. Wait, something is off. Did I multiply? Oh, guys, I dropped a 0. 1, 2, 3, 4 zeros. That's 2600 over here. I dropped a 0. I dropped a 0.
You dropped to 0.
Yeah, which means it's 20, not 8,000, but 26,000. That's why you left.
I was waiting for you to figure it out.
$130. There we go. Much better. So if the price is $130 instead of $200, we are going to have maximum revenue. Yes. It's ax squared. We haven't talked much about this. There was only one lesson in your pre-calculus. So a is always in front of x squared, b is always in front of single x, and then c is the one without x. Those are the coefficients a, b, and c in quadratic. So since 26,000 is in front of single p, that must be b, and negative 100 is in front of p squared, that must be a. So if the price is dropped all the way down to 130 from 200, you are actually going to have maximum profit. So driving the price down sometimes will actually make it more people buy it because it's more affordable. And it's always, you see, you can get more money through crowdsourcing than through a single donation, right? That's how it goes. That's what we do in Rotary Club. We have a matching donation from Bill Gates for polio plus 2-to-1. So everything we collect for vaccines, it gets technically tripled. So if we find $1 somewhere, times 3 is $3. We collect $100 from 100 people $1, right? It's actually 300. So that's the same thing idea over here. You drop from price from down, but mathematics shows that. You saw the model, you saw the calculation. Now what I want to do is I want to ask you to compute. I want you to compute the revenue. You have the equation, so you'll be plugging in for P, 120, 130, and 140. So those three prices. All right, 120, 130, 140, and you will see that, well, you will see something interesting. So compute this formula, 26,000p minus 100p squared, 3 times. Once for 120, once for 130, and once for 140. Yeah, yeah. So how much is revenue for 120?
680.
It goes up by 10.
How much is for 130?
1,600. Wait, 1,690.
And then 140?
Oh.
Uh-huh.
Got it.
Uh-huh. If you calculate 110, 110 is going to be even lower than this value, and it's going to be symmetric for 150 because the graph is symmetric. It's an even function. Well, it's not even because it's shifted, but it's a symmetric function on the vertex. No, for $10 to 131. You would make less money. If the price of the ticket is exactly 130, you are making the most money. If you drop below or go above, you will lose money. So there is only one sweet spot, and that is 130. We computed that using mathematics, and that's the end of the story for application. You drop below that number, you are immediately in the trouble making less money. You go more, because if you go less, you're not going to have enough people to counter that. If you go above, if you go less, then you don't have enough ticket price base. And if you go above, people will drop out, and then you're going to have enough people. So the sweet spot is 130. P is the price. No, P is the price. P is the price, the new price of the. So here it is one more time, and I'll put together with the. So P is the price at the moment. So price minus the old price is going to give us the difference. Okay. So this is if this is 200, 200 minus 200 is 0, 0, so you have 6,000 people flying. If this is 201, then this is 1 times minus 100 is 590. The question is asking just to find these two equations. They want the two equations, the one for n and the one for revenue. The analysis of it is what makes you money, if you want to make money. That's the, because you're probably going to want to work somewhere eventually. Right? Let's jump a little bit around. Let's talk about farmer problems. They're always fun. What happened?
Agriculture,
It could be, but we also could have animals.
You talk about corn.
Okay. The next topic is corn. So let's say farmer has 2,000 yard of fence. He wants to fence off a rectangular area. So what are the dimensions of the maximum rectangular area that he can fence off with this much fence? So find dimensions of a maximum area he can fence off. Well, we already said it was a rectangular, so I'm going to draw a rectangle. Realize that I have x and a y. I have 2,000 yards of fence. Which way does that go? Where do we put fence? Around. So what is the mathematical concept that would replace the word around? Perimeter. What is the perimeter for the rectangle that you see? 2x plus 2y, because you have 2 x's and 2 y's. You add them all together on a pile because you are going around. And that needs to be 2,000, right?
Yeah.
Awesome. We have an equation. We also want the maximum area, which means that has to be other equation. What's the area of the rectangle? Oh, give me a heart attack. And that one needs to be maximum, right? So now I'm going to box off two equations. I have this equation here and this equation here. We're going to cut and paste this problem into Calculus 1. Just like this. Also the one with tickets. Cut and paste. And we're going to ask you to solve it. Now we're going to use the calculator and cheat a little bit, or maybe use the same thing, negative b over a. In Calculus 1, you're going to use the derivative. Do the same thing. In section 4.4 in Calculus 1. Same problem, same wording, same everything. Just you're not going to use the vertex formula, you're going to use derivative to get the same answer. What do we have here, guys? We have one equation, we have the other equation here, and you want to find the model that will give you the maximum area. So, solve this problem for one of the variables, plug it in the area equation. You will see this is going to be called objective function, and this is going to be called constraint. So you plug constraint into objective function. Objective function is what you want to get. And objective, this problem is to find the formula for the maximum area, which will spit out x's and y's. So because there's two variables there, we're going to solve this equation for one of the variables, plug it in, and then you will only have, like substitution method, and you're going to have only one variable floating around. So, from the top equation, I'm going to write, first, divide by 2 everywhere, x plus y is 1,000, and then, let's solve for y, say, is 1,000 minus x. Now we plug that in here, and we get that instead of, we have x times y is 1,000 minus x, we just did that, is equal to a max. So what is the area as a function of x? Area as a function of x is 1,000x minus x squared. That is your mathematical model. I hope you understood this because you passed algebra, which had 2 equations and 2 unknowns. All I did is a substitution method. I solved this equation, like the non-min max equation. I solved that one for, you can solve for x or y, doesn't matter. You solve for one of them, and then you plug it here. So this x is this x, and this y is the y, right there, which we know what y is. So that's the y equals to max. And now we have the equation for the area. When you distribute this x, you get 1,000x minus x squared. Again, you observe the negative x squared term, which means the parabola opens downwards, which means it has the maximum, which means the vertex is the maximum, which means that by computing the vertex, you will know how much x is. So, computing the vertex, we need to go, what? What was it? Exactly. Okay. So negative b, that's going to be negative 1,000 divided by 2a, which is negative 2 times 1, negative 2. The whole thing is 500. So x is 500. how much is y if x is 500? So, since y is equal to 1000 minus x, that means that y is also 500. And we got what? A square. Square is the rectangle with the maximum area. So it's a 500 by 500. And if you want to check, use some common sense. Is it 2000 around? It is, right? Because you have 4 500s. 4 times 500 is 2000, which is how much fence we had. Now, once you understand this basic problem, we can start messing with it. Let's say that this plot is adjacent to the river and you don't need to fence that side. What do we do then? Is it different or the same? So here's the river. I'll put some salmon in it. Yeah. Yeah. If the salmon is going this way, which way the water goes?
That one. That one.
The correct answer depends on the time of the year, because salmon eventually has to come back. I know. That's why you take the math class, right? Think about it. Awesome. Got you on that one. All right. Here's your rectangular plot now. We still have 2,000 yard available. 2,000 yard available. Does anything change?
Yes.
What changes?
The x should be multiplied by
For what?
or for the p.
For perimeter. You see, so perimeter has only one x now. You have two y's. So p is equal to x plus 2y equals to 2,000. And the area equation remains the same because the area of the rectangle is always x times y. And now you get to redo the problem. It's going to give you different numbers because we are not fencing off one. And you're not going to get square this time. So what do we have here? We have, let's go with x now. X is equal to 2,000 minus 2y. So for area in terms of y this time, is going to be, instead of x, I'm writing 2,000 minus 2y, and then all of that times y, and that's 2,000y minus 2y squared. So if I have those, I see, again, the vertex formula, negative b over 2a. I can compute negative 2,000 divided by negative 4 is 500. Didn't we get 500 last time? Yeah, we did. But look what happens for x value. So that's your y. Y is 500. Because the function was in terms of y. When you solved for the vertex, you got your y. Now, what is the x? X is 1,000 now. So we have 1,000 by 500 yards. 1,000 yards by 500 yards. That's the new dimensions for the maximum area if this is the configuration. How is it different? No fence on one side. Okay, let's try it again. How about let's go with this. Let's make bins like this. All right, so we are making now I'm coming up with stuff. So we have this configuration. We have, I don't know, You gotta separate here. Carrots, rabbits, and tigers, whatever. Gotta separate the stuff, or cabbage. Yeah, I know. So you definitely don't want to put the rabbits with the cabbage. They're gonna eat it, or carrots, whatever. You don't want to put rabbits and tigers. You put them next to it, just scare them. So you separate them all. Because this changed everything in calculation.
Oh, yeah.
I still have 2,000 fence yard, right?
So now it's going to be a 4 from the y, and it's still 2 instead of a.
Very good. I have x over here. I have x over here. And then I have y, 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 because each one of these black lines is going to be a y. So I have 2x's plus 4y's is equal to 2,000. And the area is still xy, which needs to be a max, right? So you want to make sure that you have enough room for what I put there? Carrots, rabbits, and tigers, right?
Cabbage.
Cabbage. Cabbage, rabbits, and okay, fine. Tigers. You solve it the same way. Solve for either x or a y. Hopefully you will solve for x. Plug it in. You can practice on this one. Show off your math skills. You got 250 and 500.
No. So from the original equation, 2x plus 4y, so that x plus 4y equals x at 100 out. No, it doesn't, because he did 1,000 minus 2y, not 4y. He did 50.
I divided the whole equation by 2. Yeah. You always reduce the.
Okay, well then I just keep my x there.
You must get the same answer.
I did. I got the same exact answer, so it doesn't really matter how I did it, as long as I got the right answer. I can figure it out. I can figure it out.
Wait.
I did that too.
See, but I showed my work. I did show my work. I mean, I did show my work.
2a. A is negative 2. Here. 2a.
But I got that answer, so I mean, I'm fine.
Okay. The last thing we're going to do today is a challenge problem.
Oh, what?
A challenge problem. I'm hoping that all of you will take this problem home, build the box, and bring the box next class because you love this stuff and you love to explore and learn things. Don't try to bend your laptops and tablets. Do the paper.
It's a joke, right?
So what can we do?
Oh, yeah, it's fine.
So the challenge for you guys is to take this single sheet of printing paper. Don't take this one, she needs it apparently. So you take a single sheet of paper, and the job is to build the largest possible, volume-wise, box with a square base and no top, no cover. So you only have 5 sides. There will be a bottom side, and then there will be 2 sides like this. It will be open, so it's like a box you can put stuff in. So the job is to take a single piece of paper and build the largest possible box, volume-wise. So the box with the largest possible volume at the making sure that you have a square base, because if the base is not square, then it's called a 3 problem. So the square base, and you will actually have to cut this paper, obviously, because you don't get the square base out of the rectangular shape. So you'll have to figure that out first. Now let's do the.
You're joking, right? Like, you don't actually have to bring in a paper box to class.
You don't have to. No one said you have to. I'm giving this as a challenge to those who want to.
Are you gonna grade it or something?
No. It's just going to be for cool people. I mean, for those who I consider cool. There's a difference, right? I mean, I have to experiment to some basis as well. You choose which club you belong to. What? You probably will, because you will practice enough. You will know what you have to do. So yeah. Let's take a look at the problem. Of course, there's a problem. So let's say that I have a piece of paper that it's 20 by 20 inches, because the common sense says that if you are trying to build a box with a square base, you must have a square paper to begin with. So the job is to cut out the four corners with the unknown incision x, so that once you fold the edges up, the object you create is the box which would have largest possible volume. So looking at this box, each one of these parts here are sides. These guys get thrown out. You cut in and just throw them. And you can, once you fold these up, up, and up, and up, use a piece of tape. Some of you who are extra cool, you're going to decorate that. I have some of the ones done in my office, which is awesome. Some people take time to take, collage paper and cut out different shapes and glue them to the thing. Some people color it. Some people write the math that is involved in computing that in the middle. So you can be as creative as you want to make it look cool. But it is extremely good exercise, and I don't know, it's fun. So now, how do you build an object of a maximum volume? There is no way that you can guess this, and there is no way that you can do the trial and error on this. You actually have to compute it, and then once you know what you have to cut out, you cut out and just fold it up. So building this will take, if you're just going to take the basic toilet paper like this and just bend it up, it should take like a minute to cut out 4 boxes and fold them and glue them with. But if you want to make it nice, you can spend hours on it. It's cool. All right, so how do we do this? Well, I am taking the square paper 20 by 20, and I want to cut out these x's. So now, what is the volume equation equal to? The volume equation is going to be a side of the box times the other side of the box times the height. So how much is the height? That's the easy one of the box. Looking at the picture, x. Height is x, right? Because you're cutting out these little squares, x by x, and when you stand that up, clearly x is the height. So the box has a height of x. But now, what are the length and the width of the box? No. 20 minus 2x, exactly. So you have 20 minus 2x squared times x. Because you are taking 2x from each end, right, x and x, and that's your length. And you're doing same thing for the width. So you have 2 of those. They multiply because the volume of the box is x times, right, length times width times height. So length and width are both 20 minus 2x, and height is x. Now, the cool thing over here is you only have one equation, so there's no plugging in or anything like that. You just solve this one and you're done. So volume in this case is going to be, now you square this. When you square it, you get 400 minus 4080x plus 4x squared, everything times x. Put them in the descending order. So we have 4x cubed minus 80x squared plus 400x. So this is your mathematical model. You want to make this equal to a maximum. So you want to know for which x this has a max value. For which x this has a max value. Now in calculus, this would be a much easier problem. In pre-calc over here, you will have to suffer a little bit. And you have to use some common sense as well. Because you have to guess the answer. You can't, and you have to guess the range on which to look for the answer. Yes? Yep. Values less than 20. Now your calculators, TI 83, 84, have the maximum feature on them. So you can use that one to figure out where the maximum is. You would plug this in your y equals this equation. So I have 4x cubed minus 80x squared plus 400x hit enter. So once that is in your calculator on the y equals, you can go and use the second calculate, and it will, number 4 is maximum. Left bound, put it at 0. Right bound, put it at 20. Something is wrong, give me a second. We graph it first. So once you push graph, it should show you a graph. Then you go into second calculate, which is the second trace, and then calculate the maximum. What's the thing that does it? Someone's phone or? Left bound at 0, right bound at 20. What?
Yeah, that would be.
I'm constantly getting error. I'm not sure why. All right, whatever. Eye it on the graph. So graph. Second calculate max. And the calculator gives me 3.33. So I have to cut out, if it's 20 by 20 inch paper, I have to cut out 1 1/3 of an inch. So I get the maximum volume. So that means that it's 20. So the side would be 20 minus 6.66, which is 13.34 for each side. So the box would be 13.34 by 13.34 by 3.33 inches to have the maximum volume. You can find the maximum using the feature maximum on the calculator. And as I said, this is for those of you who really are thinking about engineering. If you're seriously considering engineering and you don't do this project, you're just done.
What?
Because this is the kind of stuff that starts tinkering with things. So you have the problem, you will apply it to the paper that you have, figure out the sides. I know the answer already because I've been assigning this to my students in Precalc1 and Calc1 over and over and over again. So those of you who really want to be engineers and think on a brain and figure things out and start building stuff, this is the first step, and the next step will be the math club. See you all in 5 days. We are going to have a review.